Right, this is problem 215. So we are here working with forces in 3D. And in this case, they ask us to find the angle between this force that is attached to hook A and the line between the point A and point O. So they want us to find this angle over here. As you recall from the theory, we can find that angle as the cosine. Please look at the demonstration of this formula. We did it in the class or in the narrated lectures that I post. And so that will be the vector scalar, this vector AO, divided by the magnitude of each of these vectors. So in order to find that angle, we have to find these four components. We are already given the vector f, so we already have, let's do a check. We already have this vector, which is this one right here. So we have to find the vector AO and the vector f, or the magnitude of the vector and the magnitude of this vector, in order to find that angle. Well, the magnitude, let's start with the magnitude of f. That's easy, right? So if we have f, let me write it in the same color. So if f is this value, the magnitude of f will be just square root of each of the components. Right here, this is 11.22. And that force is given in kilonewtons. Actually, let me change this. As you see in the PowerPoint, this is given in kilonewtons. So let's write the units correctly. So the magnitude will be given in kilonewtons as well. So we already found the vector f that we have here and the magnitude of the vector f. Now we have to find the vector AO, right? So the vector AO is the opposite of the position vector of point A. So the position vector of point A will be 1 in I, negative 2 in J, and positive 2 in K. But since we are going from A to O, then we go negative I, right? Negative I in 1, positive 2 in J, and negative 2 in K. So we already have this vector over here. So we have this vector, this vector. So we are only missing that one here. So as you know, both the magnitude will be equals to 1 squared plus 2 squared plus 3 plus 2 squared. Which gives me the square root of 9, which is just 3. So we found that one right here. So we have the four components. Now we have to do the dot product with those two vectors. Remember that a dot product is different from a cross product. So we write our vectors, negative 6 in I, plus 9 in J, plus 3 in K, dot product, the vector that we just found, negative I plus 2J, negative 2K. In the dot product, we remember that I dot I is 1, I dot J is 0, I dot K is 0. J dot I is 0, J dot J is 1, J dot K is 0, and so forth. So the only values that we will have left is I dot I, J dot J, and K dot K. And this will give me, the result will give me a scalar. And that will be negative 6 times negative 1 is 6, 9, this is at 18, and this is negative 6, right? So that will give me 18. This is F, A, perfect. So we have this product, therefore finally the angle will be the cosine of 18 divided by 11, 22, and 3. And we calculate that cosine, and I have it right here, give me a value of 57.67 degrees. And this is the angle we were looking for, which is this angle right here. We also want to find the component of this force F along the line AO. So the component of force F along AO. There is two ways to find this force, this component, and one way I will call it FAO. And when we talk about a component, we don't talk about a vector anymore. We talk about a scalar because it's the magnitude along that line. So we already are given the direction. And that will be the force F dot product, the direction, AO. The dot product, when I multiply by a direction, is not this vector. So here is a vector, I have to find the direction of that vector. How do I find the direction of a vector? As you recall, the direction of a vector is the vector divided by the magnitude. So we already have the vector. And we divide it by the magnitude. So that gives me 1/3 in I plus 2/3 in J minus 2/3 in K. And this is the vector that I will dot product. So look at this difference. Here I was multiplying one vector times another vector, dot product. Here I am dot product, but not with the vector, but with only the direction of the vector. So that gives me that FAO will be equals to my force, which is -6I plus 9J plus 3K dot product -I, 1/3 in I plus 2/3 in J minus 2/3 in K. And again, since it's a dot product, I will multiply I dot I, J dot J, and K dot K. This is equals to -6 times -3, that gives me positive 6/3, which is 2, right? Plus 9 times 2, I'm going to write it, and we do the product, right? And this is 3 times 2/3 negative. That gives me a value of 6 kilonewtons. Finally, since I already have this value, so this is actually not a vector. So finally, I can write, let me write it right here, the component of this force along AO is equals to 6 kilonewtons. And that's the result. As I said, we can do it in two different methods. This is method 1, so to say. Let me write it right here. Which is multiplying the vector times the direction. And method 2 is actually doing that too, but as you recall, the dot product, the definition of a dot product is both magnitudes times cosine between those two vectors. Since this magnitude is 1, this is the same as saying the magnitude of this vector, which we already found, times cosine of theta. The magnitude of this vector is 11.22, and the cosine of the angle that we found, cosine of 57.67. If you do that calculation, you will find that it gives you exactly the same value using the second method, which instead of doing the actual dot product, you use the definition of dot product, which is the two magnitudes multiplied by the cosine of the angle between the two vectors. And this is the solution of this problem.